Hello geometers, as we continue our series of videos here on finding area of rhombuses when given slightly different information. So now we are asked to find the area of a rhombus ABCD where this diagonal here, no, not the diagonal, the side length here is 15. Now in a rhombus it's once you know one side length, you basically know them all because all the side lengths are congruent. And don't forget that this angle in here in the middle here is a right angle. And we're told that the measure of angle A, and I should be more specific here, it's the measure of DAB. So this is the measure of DAB. The problem here is a little bit ambiguous. But it's really this angle here, that's the big one there, that's 100 degrees. Okay. Now we are asked to find the area. And if you recall from before, we basically found the area of one of these right triangles, and then we used that area and we quadrupled it to get the area of the whole thing. In this case, it doesn't really matter what you pick as the base and what is at the height. So I'll just pick this length here as my base and this length here as my height. Okay. And this angle in here, the smaller one, is 50 degrees. Now the reason for that is that in a rhombus, the diagonals bisect the angles. Okay, so I'll just write this note here. In a rhombus, the diagonals bisect the angles. Okay. This is a theorem that we've proved before, and I'm not going to go too much into it here. Look at some of the previous videos to get a better explanation on this. And it may seem that we cannot find these two lengths because we only have one of the other lengths, but this being a right triangle, we have the ability to use all of the trigonometric ratios, sine, cosine, and tangent. And I'm going to use 50 here as my reference angle. So I can use cosine of 50 to help me find h. So the cosine of 50 is equal to h over 15. And that means that 15 times the cosine of 50 is equal to h. Then I can use the sine function to help me find b. So the sine of 50 degrees is equal to it's equal to b over 15. So 15 times the sine of 50 is equal to b. Okay, so I'm going to circle these. These are the temporary or intermediate solutions to the problem. They're not the final answers, but they're basically they're the most important parts because they help us figure out what the rest of it is. So now the area of one triangle, and this is triangle ABE, is equal to 1/2 the base times the height. But I can just make these substitutions. The base is 15 times the cosine of 50. That's a degree symbol there. Times the height, which is 15 sine of 50. And the reason I'm not typing this into a calculator right away is because I don't want to have to worry about rounding errors until the very end. So this comes out to be, I'm going to multiply out all the constants first. 1/2 times 15 times 15. So that's 225 over 2, which is equal to 112.5 times the cosine of 50 times the sine of 50. Okay? And that gives me the area of one triangle. Now if I want to find the area of the rhombus, the area of ABCD, then I just have to multiply this number by 4. So this is 4, I'm going to use parentheses here, times 112.5 times the cosine of 50 times the sine of 50. Okay. And altogether, this is not going to give me an exact answer. So this is approximately 221.582 units squared. Okay. So there we go. So when you finish these types of problems, you should really look back and see, what are the major steps. And I think in this problem, the key is using cosine and sine here to find these missing two lengths. Because after that, everything is able to, we can calculate everything else. Okay, so these problems are really just about recognizing what you already know about the shape and taking advantage of those properties in order to find the lengths or the angles that you are currently missing. Okay. As always, if you need help, please ask for it. Thank you for watching and have a wonderful day.